Lesson 3.2, the product and quotient rules. Can you use the derivative rules for products and quotients? Let's take a look at the product rule, a visual look at the product rule. What we're going to do is take a look at two functions, u, which represents f of x, and v, which represents g of x. And we're going to try to set up the definition of a derivative. But before we do that, let's work with the numerator part where we're trying to take a look at the difference of the y values of these two products. So this is delta u and this is delta v. This is the difference of the y values, the difference of the y values. And if you multiply them together, that'll be the difference of the product. So we're going to take u plus delta u. So it's the function plus a little change in it, v times a little change in v, and we're going to find the product. That'll represent this change in the product. And here is the y value with the change and the original y value, u times v. So again, in our difference quotient, we're really working with this, the numerator part right here. So when you multiply this whole thing out, you're going to have u times v, and then this times this will be u times delta v, and then this times this will be this, and this times this will be this area right here. Now when you finally subtract u and v, then we're only working with the shaded areas right here. So these shaded areas represent the change in the product, which is just that numerator part. Let's go on to the next page. We're going to now take this portion, which is the numerator part right here, and we're going to divide it by delta x, and that means each term is going to be divided by delta x. And when we do this, this change is going to eventually become a derivative once we take the limit. So the derivative, as the limit as delta x goes to 0, we're going to have the limit of a sum is the sum of the limits, and we're going to separate all of those limits. And this value can go outside the limit. This value can go outside the limit. And as delta x gets closer and closer to 0, this limit becomes a derivative, this limit becomes a derivative, this limit becomes a derivative, and as delta x goes to 0, all of those little small areas are going to 0. So this limit goes to 0, and we end up with the formula. Okay, so what does the formula say to do? The formula says when you have a product, you're going to take the function and times it by the derivative of the second function, and then take the second function and times it by the derivative of the first function. So let's go ahead and demonstrate. I'm going to find the derivative, which means I'm going to take the first function and then take the derivative of the second function plus the second function times the derivative of the first. And so now I'm going to get x times e to the x plus e to the x times 1, which I won't bother writing down. And there's my answer. In prime notation, it looks something like this, where each one of the functions gets a turn at being a derivative. Now let's go ahead and do this one. H prime of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function, and then I'm going to get x squared times 9 plus 9x plus 2 times 2x. This is going to be 9x squared plus 18x squared plus 4x, which becomes 27x squared plus 4x. Now I want you to know that there is another way to do this, and instead of doing it the way I just did, I can distribute first, and after I distribute, I have a polynomial, and I can just do the sum and power rules, and that'll be 27x squared plus 4x, which matches this. So sometimes you have choices in being able to find the derivative. This is an interesting history tidbit. Leibniz, who was one of the founders of calculus along with Newton, made a mistake, and his mistake was the product rule. At first, he thought that the derivative of a product is the product of the derivatives. And he caught his error when he was looking at when both functions are equal to x. So he said, hey, if both of them are x, the derivative of each one is 1 times 1, which is 1. And he said, wait, that doesn't make sense, because x times x is x squared, and I know its derivative is 2x. So that's going to present itself sometimes to you. You're going to want to think that the product rule is just about taking the derivative of each one, and that's not true. All right, let's take a look at the quotient rule. Quotient rule is a little bit more involved. We're going to go through the same process that we did with the product rule, in that we're going to take a look at the difference quotient. We're going to take a look at the numerator, and in the numerator, what we're going to want to do is we're going to want to take a look at the function with a little change minus the function. So the function with a little change minus the function right here. So this represents the numerator here. I'm going to get a common denominator. So here's my common denominator. And that's going to force the v to be multiplied to here and this to be multiplied to the u. And then everything's going to get multiplied, and I'm going to get this. So this is my numerator. All right, now to get the whole difference quotient, I'm going to have to divide by delta x. And so I'm going to be dividing by delta x, or when you divide by delta x, it's the same thing as multiplying by 1 over delta x in the numerator. So that's what I'm going to do, multiply by 1 over delta x in the numerator. That's where these come in. And the limit can now be, we can take the limit. The limit of a quotient is a quotient of the limits. The limit of a product is a product of the limits. So we can take all of these limits. This doesn't involve delta x, so that can be removed outside the limit. And then this ends up being a derivative right here. And we can take u out of the limit expression, and this represents a derivative here. And v can be moved out, and as delta x goes to 0, all the small changes also go to 0, and this will be v. So v times v is v squared. Okay, so here's what the quotient rule looks like. It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. And in prime notation, it looks like this. And Stewart has given you a hint to maybe use words to help you. Okay, let's go put this in practice. All right, I want to find y prime, which means I am going to take the denominator and times it by the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So this is going to be x cubed plus 1 times 2x plus 1 minus x squared plus x minus 2 times 3x squared all over x cubed plus 6 to the second power. Okay, and to match the back of the book, or to match maybe an answer in a multiple choice format, you're going to have to multiply all this out, simplify, and then match it up. Now on the test, we'll be okay with you leaving it in this form. We'll just assume you guys know how to simplify. Okay, so we want to find the equation of the tangent line of this quotient example at the point 1, 1/2 e. And so again, I'd like you to see that we are taking the denominator here. Here's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And we're going to find those derivatives, and we're going to simplify the expression. We're going to insert 1 in here, which means that this quantity is going to be 0, but the quantity down here is not 0, which makes this whole derivative 0. So we know it's a horizontal line. Horizontal lines are always y equals, and so it'll be y equals this number. Now, in conclusion, here is a table of differentiation formulas that we've had so far. This is the end of the screencast.